Okay, so this is question number 4 of the nuclear physics homework booklet. And in question number 4, we're basically looking at the radius, well, the nuclear radius. And we're told that the radius of a nucleus, is given the symbol big R, is related to the nucleon number by this equation here, where R0 is a constant, it's just some number. And we've got a list of different values for the radius of different elements, and it also tells us what the nucleon number for each of these elements are. So we're given some information in the question. But so far we've just got information. We need to actually see what the question is going to ask us, and then we'll come back to this in a second. So we're asked to use data to plot a straight line graph. So somehow we have to make sure our graph is going to give us a straight line, and then once we've done that, estimate the value of R0. So what I'm going to do is this. I'm going to say, right, okay, so a straight line is generally has the equation y equals mx plus c. So I'm going to cube this thing. And if I cube this thing, I get r cubed is equal to r0 cubed multiplied by a. So if I compare that with this straight line, if I plot r cubed on the y-axis and I plot the a on the x-axis, then the gradient will give me r0 cubed, and it should go through the origin because the constant, there isn't a term over here, so this constant, the y-intercept is 0. So I should get this as my gradient. So the very first thing I'm going to do is I'm going to use my table, and I'm going to work out what r cubed is. So all of these numbers are times 10 to the minus 45 meters cubed. So I simply took these numbers and cubed them. So 2.66 cubed is 18.8, and so on. What I'm then going to do is I'm going to plot a against r cubed. And if I do that, I end up with a graph that looks, it's a nice straight line and looks like this. So I've got my a on the bottom, so 25, 50, 75. I've gone up in 25s up the side as well. I plotted my points and I got a nice straight line like that. And then if I go back up here, I've got a straight line graph. I now need to work out what R0 is. Well, the gradient gives me R0 cubed. So I'm going to work out the gradient of my graph. So if I go back down here, what I did was, you can't see all of this on the screen, but I've drawn a line down here, right down to the bottom, and a line all of the way across. This is 200 all the way to here. This was 287.5 up the side. So if I go up here, my gradient was 287.5. Don't forget that the times 10 to the minus 45 from my table. Divided by 200 gives me this number here. So my gradient is this number. And if you remember, my gradient was r0 cubed. So if I take the cube root of this number here, that'll give me the radius, and it gives me if I take the cube root of that, it'll give me the r0. So that gives me 1.1 times 10 to the minus 15 meters. So there are a fair few ways you can answer this question, basically in terms of marking points. If you plot a suitable graph to make it a straight line, so you can plot r cubed against a, you could plot r against a to the power of a third, or you could plot the natural log of r against the natural log of a. If you do any of those things, you get 1 mark. You'll notice I've put units on my axes where it's appropriate, so it's only appropriate on the y-axis, but you get a mark for that. There's a mark for using your graph, so it uses more than 50% of the paper. There was another mark for making sure the data in your table was correct, so that's this data up here, really. So if all of that's right, then you get a mark for that. There were 2 marks for correctly plotting your data, so you lost 1 mark if you made 1 mistake. So provided it's plotted in the right place, you get 2 marks. You get 1 mark for correctly calculating your gradient, and what I'd really like to see is a really big triangle. If you don't draw that, it makes it much harder for the examiner to check where you've got your numbers from. And finally, your final 8th mark for actually calculating R0 correctly. So you should get something in the region of 1.1 times 10 to the minus 15 meters. You're allowed somewhere between 1.0 and 1.2. So that was part A. In part B, we're going to assume that the mass of a nucleon, in other words, mass of a proton and a neutron, is this number here. So it's 1.67 times 10 to the minus 27 kilograms. We're then asked to calculate approximately the density of nuclear matter, and then we've got to state one assumption that we've made. So to calculate density, I need the mass divided by the volume. Well, the volume I'm going to assume is a sphere. So I've got a nucleus that's a sphere. So I can write down what my assumption is already. I'm going to assume that this nucleon is spherical, basically. So the volume is 4/3 pi r cubed. R is basically the R0 that we worked out before. So R0 basically tells you the radius of one particular nucleon. So this is the number that I got from my graph. You would use the number that you got from the gradient of your graph. And if I do that, I get a volume of 5.575 times 10 to the minus 45 cubic meters. Density is then mass, so 1.67 times 10 to the minus 27, divided by the volume I've just worked out, gives me two significant figures, 3.0 times 10 to the 17 kilogram meters cubed. Kilograms per meters cubed, there should be a minus sign on there. So basically, I get 1 mark for actually working out the volume correctly using 4/3 pi r cubed. I get 1 mark for the density part, I get 1 mark for the answer, and then finally I get 1 mark for my assumption. So that was question number 4 of the nuclear physics homework booklet.